Hello students. In this video I will review some of the material from Chapter 1 using the PowerPoint, which is also available on Blackboard. So Chapter 1 talks about graphs and tables, and we start with our discussion of descriptive statistics. As it says there, it helps us organize data, large data sets, in meaningful ways in order to find trends, highs and lows, etc. Our first lab exercise and lab assignment we'll be using a large data set and trying to find ways to make sense or summarize that data. So there are 4 different types of data. Knowing the 4 different types of data is important because it allows us to use the correct calculations and analysis on it. So 4 types of data: nominal, ordinal, interval, and ratio. So nominal data, another name for nominal data is categorical data. Numbers there are just for naming purposes. Mathematical calculations are meaningless, only counting of each category. Categories are mutually exclusive. That's an important term. We'll come back to that in Chapter 3 as well. But basically that means that each piece of data goes into one category. And then by default there has to be a category for every single piece of data. So some examples of this would be, eye color, types of vehicles, color of vehicles, gender, hockey jersey numbers, for example. They're there just to help us make sense out of that type of data. Ordinal data, basically it's nominal data that has been placed in order to show rank or to show relative order. The greater the value, the greater the rank. There's some mathematical calculations that are possible. The key here is that intervals between the values are not necessarily equal. So some example would be satisfaction surveys or Likert scales, things that you have done when you have completed course feedback. Do you agree with the quality of the food in this restaurant? You can go from very satisfied, satisfied, neutral, unsatisfied to very unsatisfied. There's a scale, and the scale is in order. Or you go to the doctor's office and the doctor asks, how much pain are you in on a scale of 1 to 10 or 1 to 5? So indicating 4 or 5 means you are in a great deal of pain. Versus someone who says that they are only, in 1 or 2. So it's a relative, it's a subjective scale, and the doctor in this example may not be asking, to see who is in the most pain. I will see first. It could be, how much pain are you in now? And I'll give you some medicine, apply a treatment, and see if that treatment works based on your assessed pain value afterwards. Finishing first, second, third in a race would be another example, or in certain situations, income and age could also be ordinal data if they are placed in, if the choices are placed in order. It's very difficult to get people to indicate how old they are or how much income they have, or how much income they make, but if you put that in order, like 18 to 20, 21 to 23 kind of thing, or 50,000 to 60,000, 60,000 to 70,000 kind of thing, would be an example of ordinal data. Interval data. Here the key is 0, does not indicate absence of a measurement. For example, 0 degrees on a Celsius scale. It does not mean that there's no temperature. So a good example of this is Celsius or Fahrenheit, the time that you have when you finish a race. Those are good examples. Ratio data, it's a special type of interval data. Some textbooks, if you're using other textbooks, may categorize data in 3 types, being interval, ratio being a subcategory of ratio, but some textbooks just say there's 4 types of data, and that's what I'm using here. Numbers can be compared to each other. They can be multiplied and divided. Income and age, when they are the actual specific number, like you are 32 years old and you make $4,000. That would be ratio data. Kelvin scale is also ratio data because 0 here represents the complete absence of a value or characteristic. If you have 0 income, you don't have any income. 0 degrees Celsius, on the other hand, is interval data because that does mean something. A dress size that comes in size 0, does that mean no dress size, or does that mean that there is a dress size called dress size 0? So dress size, just to stop you from wondering, is interval data. Here is a breakdown of the 4 types of data, and there's dress size under interval data. So what data is, what are some of the problems with collecting data? What data is easier to collect? Basically, the easiest data to collect is nominal or categorical. You basically ask people specific categories. It could be favorite color, type of car they drive. It's really easy to collect. Where they live using their postal code would be really easy data to collect. As we move down from nominal down to ratio, it becomes more difficult. Ratio data, what's your precise age? How much money did you make last year? People may or may not know those answers, but even if they did, they may not want to report their exact age or their exact income or their exact debt. Which data is more robust in terms of usefulness? Ratio data, far more useful than nominal data. A lot more calculations we can do with ratio data. So ratio data is the most useful. It's also the most difficult to get. So this example is on page 9. We're going to look at 3 different types of data: gender, income, and credit score, and determine if it's qualitative or quantitative. We took that back in the intro chapter. Discrete or continuous, and whether it's nominal, ordinal, interval, or ratio. So let's see if I can write here. I believe I can. So gender. Gender is going to be qualitative. I can't write. Let's see. There. Now I should be able to write. So qualitative. You know what? It doesn't work too well, obviously, when I'm writing into PowerPoint. So just have to bear with me. Gender is qualitative. Income is quantitative. Quantitative being amount, so income is quantitative. Credit score is also qualitative. Discrete or continuous, gender and credit score are discrete. Income is continuous. And gender is nominal, income is ratio, and credit score is ordinal. So the categories, good, average, low, those categories, those choices are placed in order. So that's why it would be ordinal data. So we move into constructing tables. Basically, ungrouped raw data, that's defined as data that's not grouped or categorized. It's a list of data, and that's where we start off with lab exercise 1. We take that ungrouped data, that massive list of data, we want to group it. We want to put it into a data table, and we then count the frequency of each class as compared to the number of items we have. So the first thing we need to do is determine the size and number of classes. Approach A is an intuitive approach, common sense approach, great for data with ages or grades. Approach B is using the Sturgis method, which has these two formulas here. Optimal number of classes, OOC, is 1 plus 3.33 times log of n. And n is the total number of pieces of data we have. And then we take that optimal class width, OCW, the range. The range is the highest value minus the lowest value in the data set, and divide that by the OOC number we calculated. So we can look at some examples. These examples are on page 10 and 11 of your course notes. So let's go to our course package here, 10 and 11. So let's just work on with the temperature of the last 50 days. Log 50. So if you don't have a log function, you can go to Excel, go equals log bracket 50, and there's that log number, 1.69897. If your calculator has a log function on it, great. If it doesn't, I've explained this in that yesterday's class videos, that you can use Excel to help you with your assignment, and with the quizzes on the exam, I'm going to give you what that log number is, because you won't have access to Excel. So in this case, we have the temperature of the last 50 days, the log number we've calculated, the highest value is 34, the lowest value is 2. What we want to do here is take that, or calculate the optimal number of classes, which is 1 plus 3.33 times log of 50, which is this number here. And we get an OOC number of 6.65. OCW number, optimal class width, is the range, which is 34 minus 2 divided by the OOC number, and we get an OCW number, optimal class width, of 4.8. Now this is a starting point. Let's just highlight that number. Right, this number is a starting point. We are not going to pick a class width of 4.80655. We're going to use this to help us understand that the best class width is probably going to be 5. We could use 4.8, we could use 4, we could use 5. We want to pick a value close to that. What we would not pick is a value like 10, because 10 is too different than 4.8. The closest, nicest number would be 5 to use, and that's going to be our class width when we go ahead and create this data table. So that's how we calculate the OOC number and OCW number. With the midterm marks, the log number is going to be different. It's going to be log 40. And with the NHL, there's 30 teams, so it's going to be log 30 instead of log 40 or log 50. The log numbers are mentioned in the course package. We have, then after we calculate that class width, the OCW number, we need to then go into determining the class boundaries. Where do we actually start? If you look at our data, our lowest value is 2, so we could start at 2 and go up to 2 to under 7, for example. We could start at 1 through 6, for example, or we could start at 0 and go 0 to 5 and 6 till 10 kind of thing. So with these class boundaries, we need to set clear limits. There's no overlap. They have to be mutually exclusive. Every observation must be included. And the boundaries depend on there's various examples. So example 1, 0 to 10, 10 to 20, it's not clear because you got a value for 10 that could go in both places. With set 2, the boundary, the class size is different. Class 3 and class 4 work really well based on different types of data. So 3 and 4 are good, 1 and 2 are not.